We're going to take a look at example 4 on page 732. Now, when we look at this one, there are two methods to determine whether or not vectors are equal. I'm going to show you the alternative method, and there's a little bit of variation even on that from what's in the book. Two vectors are equal if they have the same magnitude and direction. So the easy way to actually test that is if you verify the length and if you verify the slope. So if you know the length of the vector and you know the slope of the vector, then if they're the same, they are equal. If either one of those things don't match, then they're not the same vector. Now, if you already know the position vector, so let's say that you had already found the position vector. So if you know the position vector for both of them, and if they're different, you know that the magnitude is going to be different. So this is assuming that you don't know the position vector. So let's say in example 4, it says that you have a vector whose initial point is 5, -3, and the terminal point is -1, 2. And you have another one, we're calling this one B, and you have another one whose initial point is -1, -3, and the terminal point is -1, 2. And remember that initial point and starting point are the same thing. Terminal point and ending point are the same thing. So in order to verify slope, you actually do have a formula for slope that you learned probably a long time ago. And I tend to verify slope first, because if I verify slope and they don't match, then there's no sense in doing the distance or checking to see if they have the same position. So when I look at this and I try to verify the slope, and I take the second y, so 2 minus 3 over the second x minus 1 minus 5 would be 2 plus 3 is 5 over minus 1 minus 5 is minus 6. So the slope of that first vector v is -5, 6. If I do the second one, the second y is 2 minus 3 over minus 7, subtract minus 1, and I get 5 over minus 7 plus 1 is minus 6. So they do indeed have the same slope. Now, if they have the same slope, that means they have the same direction. So you don't need to find the angle measure, which is what the book suggests that you do, but that's actually more work than this would ever be. So the next thing that you do to verify that they're the same is that you verify that they're the same position vector. And if you look at the bottom of page, let me find it, the bottom of page 729, where you have a template for position vector, if that's also the same, then these are the same vectors. So if the position vector is the same, which is the magnitude, and the slope is the same, the position vector is not actually the magnitude, it's just a different place to put the vector. But if the lengths are the same of that position vector, if it's the same position vector, they will be the same length. So if they're the same vector, they're the same length. So what you're doing here is you're not verifying the magnitude and the direction. You're saying, are these two vectors the same position vectors? And if they are the same position vector and they have the same slope, then you know that they're the same vector. So if I'm trying to verify the position, I take the second x, which is -1 minus 5, and the second y, which is 2 minus 3. And so this position vector would be -6, 5. So that's the first position vector. The second one would be -7 minus 1, which will be -6. And 2 minus 3, which would be 5. So they are indeed the same position vector, and the slope, finding the slope of each vector will tell you that they are the same direction. So if they're the same position vector, they have the same length if they're the exact same position vector. And if they have the same slope, they are pointing in the same direction. So if you verified that they're the same position vector and they have the same direction, then those two vectors are equal to one another. And so that's how you verify whether or not the two vectors are equal.